I have a jam-packed presentation. I'm going to try to fit it in so that Kate has time. Also, not to give James, I'm sure he would gladly take the opportunity after my time is up to try to run up here and tackle me. So I'll try to do that before I give you the opportunity to do that. So I really only have two objectives for this presentation. The first one, just to maybe display what I kind of did with my project, because you second-year part-timers, you will be inevitably at the end of the week be getting some information from Andy about your project, and just to kind of get the wheels turning of maybe what some of the things that you can do. I remember coming to this last year, and it was really advantageous to kind of just talk to other people and see what they were doing, and then they can kind of bounce ideas off of me. I can tell them what I was thinking, and it just kind of opens your eyes and kind of gets the ball rolling a little bit, not to scare the part-timers, but you know, you still have a lot of time to decide this, but at some point it comes by quickly, and you actually have to jump on it. And then the other objective is there is just a vast majority of knowledge in this room. I'm very humbled in knowing that I don't know everything, and there's still a lot to learn, especially in data science where the technology is changing so quickly. So I'm hoping that maybe you can just strike up conversation if you see something that I was kind of doing, and you're like, oh, Jason, you know, you were talking about using OpenCV in this part, but have you thought about using this other package? It's better, it's quicker, it's faster, it's easier, or whatever the case may be, and I'll say no, because I don't know about that. So those are just kind of the two objectives of kind of going through this. Okay, so my project, it really broke down into two phases. The first phase was I was just building a model specifically using neural networks to predict weekly productivity of NFL American football athletes. And then phase two was to use those projections to optimize what's called a fantasy lineup in a daily fantasy sports platform, specifically Fanduel. If you don't know sports, you don't know what fantasy sports are, you don't know what Fanduel is, that's fine. All this stuff can translate into other domains as well. I'll talk a little bit about Fanduel and how that works, but the bottom line of it, it's just a game that you play, and it's a form of gambling. There's debate in the U.S. about whether or not it is, because the government wants to tax it, but the argument is there's a skill involved with it. It's not just randomly playing a lottery. So they're trying to find different ways to make it legal in the U.S., since sometimes it's not legal to actually play it. So I'm going to try to explain my 5 months of work in 5 minutes. So stay with me. So I start with historical data of the NFL, which is the American Football League statistics, and it dates back to 2000. So at that time I had historical data from the year 2000 to whatever the current state was at that time, 2016. It had every single player for every single team broken down by every single play. So you can aggregate that up to how they perform in the game, how they perform for the week, how they perform in the month, so on and so forth. So I took that data and I went into Python, and when Mark tells you that 75%, whatever the number is, majority of your time is here cleaning the data. And for some people that's the worst part. I actually didn't mind it. I didn't mind spending 3 months of trying to figure out. I had also the data of the weather, and some of the weather was in Fahrenheit, some of the weather in Celsius, a ton of missing data. How am I going to fill that in? So I spent a lot of time cleaning that data, putting in information that was missing, trying to figure out different types of features that I thought might be important in trying to predict how a player would perform. And then also just getting it into a form, because I was using a neural net over here at TensorFlow and Keras. It's specific in kind of the format that you put it into. It's got to be numerical and scaled and all that kind of thing. So once I had that done, fed it into TensorFlow using the Keras library, and then just trained the model. Once the model was trained based on those features and the information from the historical data, I would go back into the database and then find the upcoming week information. Because now that I had the model trained, now I want to get predictions of how the players are going to perform. So I would put that into the model, and then I would get that week's projections of how the players would perform. Okay, that was the phase one part. Phase two then was to take that and then using the rules of Fanduel to try to put those into it to perform in the contest and see how they go. So before I kind of talk about that, here's how Fanduel and fantasy sports work. You have 9 positions that you're trying to fill by position: quarterback, 2 running backs, 3 wide receivers, tight end, kicker, defense. Again, it doesn't matter if you know what those things mean, but basically you have a list of quarterbacks that you want to pick from, and then Fanduel assigns them some type of virtual value. And based on my projections, I would just pick one of the guys that was projected to perform well. So, put Russell Wilson in for my quarterback position. Then you have a list of running backs. I have to pick 2 of those guys. So again, going back, look at the projections, see how they're going to perform. Let's pick these 2 guys and put them in there. And then we just continue on till you end up filling up your lineup. And then there's your lineup to submit to compete within the Fanduel platform, and other people are doing this as well. So we're ready to submit the lineup. Unfortunately, we can't. One of the rules in the contest that I was participating in says that you have to have a salary cap here of $60,000. So in this case, then, we would just look at our lineup, and I would just trade out one of the guys for a cheaper guy. So these are your kickers. They're kind of inexpensive players, so I can just trade him out, put in a guy who's a little bit cheaper. And then we're underneath that 60,000 threshold. We're good to go. We can submit that lineup. Okay, so using the projections, using those rules, I would go back into Python, and then I would create optimized lineups from that. So this would be an example of the output that I was getting. So here's 1 team, here's 2 teams, here's 3 teams, and I can go in there and I can tell Python, you know, I want 100 different lineups, I want 1,000 different lineups, and it would just rank them as this is the best team, second best, third best, and all it was doing was taking my projections to maximize them while staying underneath the restrictions of the 60,000. And then we'd upload it in there. Okay, so the results. Did it work? Yes, it did. Sort of. You can't really see because of the colors, but what you can see is from the pattern. There's 3 different models that were used here. One was mine, and then there were 2 professional ones that you would pay for to get results from. So these are predictions from certain players for a certain week. You can kind of see they all kind of follow the same little pattern there. So in the sense of working, it worked that it was giving me results that were comparable to the professional ones, so that's kind of cool. But it wasn't working in the sense of if everybody's using projections that are similar, then there's really no advantage or disadvantage of winning the contest if everybody's just using the same type of numbers. So I couldn't just hand over a stack of money as my thesis. I actually
No, you can't.
that was kind of the hope that I win $1 million, and then I could just say here's $1,000 for my thesis. No, I actually had to sit down and type up the 50 pages. But on the other hand, I didn't bet the house. I didn't lose the house. I'm not living in a cardboard box. Although choosing to stay and live in Dundee, some people there might say it's just a step above living in a cardboard box. I'm just kidding.
He stayed because he likes the place.
So, after my project was done, I started to go back and think of different ways of maybe to improve it that can give me an advantage. And one of them was when I was doing this, I was using the linear regression, which is just giving me pinpoint values for those players. And I thought maybe I'm trying to get too distinct, and there's too much randomness when you talk about human behavior, especially competing players against each other. Like there's a lot of things that can happen and don't happen or could happen. So I thought about maybe just turning it into some type of a classification. So instead of doing exact values, maybe it can classify, and I don't know in what ways I would classify, and this is just an example of it, but maybe I can find, here, these 2 guys, maybe looking at the linear model, and pick them to be really, really high, a lot of points, but if you kind of classify it, and they might score a lot, but it's a good chance they're not going to score anything. So putting these two guys in a lineup just going to kill all my fantasy lineups. So if I can drop out the guys that maybe were high risk and just optimize out of the guys that I felt confident with, maybe that would increase or improve the overall lineups. The other idea that I sort of had was, I was doing the machine learning up here with the projections. The optimizations of the lineups were strictly just using those projections in the rules. I wasn't looking at any type of patterns that the combinations of the players might have. So if maybe I switched the machine learning here and had the machine configure those lineups, maybe it saw something, some type of pattern like if I had two players on the same team that were wide receivers, those teams did really well. Or if I had a quarterback from one team and the running back from the opposing team, those lineups would never do well. So maybe there's a pattern here that could be used to create an optimized lineup. I did not choose to go into that afterwards. I was already doing enough machine learning. I wanted to do something different. So one of the things I kind of thought of was when I would submit a lineup, I wanted to kind of track my players to see how they're doing. Just makes it more interactive while watching football. So there's this thing called the NFL Red Zone. And what it does is it takes you, at any time there's about 8 or 9 different games playing at the same time. And it takes you to the games that are interesting or not boring, although some people, like my wife, might say the whole thing's boring. But you're not interested in the downtime. So what this would do is they would go game to game, and then what I was doing is I would go to my table of my lineups, and I would try to filter through it to see, okay, this is Dallas in New York. So okay, I'm going to go over there and click on Dallas in New York. See who I had going. Okay, now they're switching games. Okay, now it's Minnesota, Carolina, so let's go back and filter and go get Minnesota players. Who do I have going for Carolina? Okay, those are the guys I had going. Okay, switch again. Oh, Dallas and New York again, go back to Dallas, go back to New York. So you can kind of see how annoying this would be if I'm just trying to sit down with a beer and watch football. I'm sitting at my computer instead trying to filter through it. Now obviously, when I was doing this, it wasn't as messy over here, like I had it cleaned up, got rid of duplicates and all that kind of stuff. But I thought there's got to be a cooler way to do it. So I just thought, let's use data science to kind of automate that whole process. So I have all my lineups that are stored. I did 150 of them, so I'm trying to track all these players. All I had to do was identify which teams were showing on the screen. So this is Oakland and Kansas City. Find all the players here who are in Oakland and Kansas City, and then just display them. And then I can just put it right up on the screen, sit back, watch, and I can kind of follow which players I had going for the team as it switched. So that would just repeat. So I thought one way of doing it is use object detection, step and chasing pictures today. And this is with TensorFlow's object detection API. They have pre-trained models that you could use, so I thought that'd be kind of a fun thing to play with. So that was why I kind of chose to go this path instead of the machine learning kind of path. And so here's an image outside my flat in Dundee. It's not a cardboard box. One of the cool things I liked about this one, it found it has a car, truck, person, and if you zoom in here, it even notices that he's wearing a back. Andy, is that you? No. Is it? Do you ever walk down Blackness Road? No. Okay. I just thought of that right now. Yeah. No, I thought like the jacket and the backpack are like they're so similar in color. I was really impressed that I was able to pick up.
Somebody said my talk was creepy, Jason. You're videoing Andy.
Yeah. So I thought kind of using that same idea, using the team logos and their kind of uniforms. So I created a customized object detection because the TensorFlow one's already trained on certain objects. So I was just trying to detect 2 different teams. So this is the Chicago Bears are these guys, and these are the Green Bay Packers. So just a couple examples of what I did right after I was stalking Andy. And it was turning out okay, not too bad. But then I wanted to try it on live video to see how well it would do, not on the still images, but on the live ones. And you can kind of see it's a little bit jumpy. Now, in defense, I didn't train it very long. I didn't use a ton of images or data sets just because I wanted to get it done to see if I can get it to work, how it would work, and things like that. And sometimes you can kind of see it kind of mixes up the players and stuff like that. And that was just using the 2 teams. I wasn't even including all the other types of ways to identify those 2 teams. So I started immediately thinking of some of the issues that I was going to run into, and that's when I was doing these custom labeling. You have to do it manually. You have to actually take the image, draw a box around it, and then label it. And I'm sure there's an automated way to do that, but that's a whole nother thing that I didn't want to get into. So you have 32 logos of the teams that you have to account for, 32 home uniforms. They also have a home uniform and an away uniform. There's this thing called color rush uniforms that they only wear on Thursdays. The teams have alternate uniforms. They have a home uniform, away uniform, an alternate uniform. Some teams have multiple alternate uniforms. What if a new team gets a new logo or a new uniform? I have to go back and redo that. And then just identifying the image. What if the weather conditions start messing with it? If it's raining, can it pick up that? If it's snowing, if it's foggy, is it going to be able to pick up all that stuff? So I already saw that you're going to have 160 different things I have to label, and I have to do it hundreds of times because you don't want just one example for the neural network to try to pick that up. So kind of going back to what everyone else is saying, keep it simple, stupid. Each of these screens have the two names down the bottom. So instead of trying to train the neural network to learn who's on that, I ended up using an optical character recognition to read that text. And so here's just a quick example of it doing that. I added some other things too, like I can do a different Fanduel or DraftKings. Upload the lineups. And then it kicks off. So I have Washington and New York. Show me who they're there. Here's my one player from Washington, one player from New York. It's going to change in a second. Cleveland and Pittsburgh. There's my Cleveland, there's my Pittsburgh. So now I can sit back with my beer and just watch the game. So since I had that working, then I thought another thing to kind of include in there would be kind of cool, not only have just the player names who I was trying to root for, but to see how they're performing actually at that time live. So I was able to connect it to a live game stats API. The NFL season's currently not happening, so I couldn't really test it on live stuff, so I ended up doing a simulation with that. And then just here's a quick example of it working with the simulation. So it has the players from the 2 teams, you can't see who it is, but then now I have their fantasy points so far in that game, how they're performing, how many touchdown passes, how many touchdown runs, how many interceptions, and all the information that might be interesting to me while I'm watching the games as well. Some of the obstacles that I'm sort of now running into, this is where I'm talking about, like maybe if anyone has ideas, we can start opening up a dialogue. But as it works right now, all it does is just captures the image on my laptop screen, because I can't figure out how to, because it's streaming from what's called NFL Game Pass, and I can't figure out how I can feed that into the package to read the images. Right now it has to be on my screen, grab that image, and then do all that stuff that it was doing with trying to identify the teams. The second thing that I'm trying to deal with is what I'm going to do when 2 games show up at one time. Do I Right now, it just doesn't do anything, but maybe I can have two little pop-ups on the side. And then third, like I said, this is just running off of a laptop screen, streaming. What if I wanted to connect it to an actual like cable box or skybox or something, and then feed it that way instead of internet streaming? I haven't figured out how to do that stuff yet, so that's kind of where I'm at with that. The packages that I did use for this was the Open Computer Vision and Python image library that was doing the processing of the video and the images. Take Hinter was what I was doing to display it and to give me my menu to click around on the different options. And then this was the engine that was doing the optical character recognition. And then if you have any questions, comments, thoughts, you have my name on the sheet. It's just first name, last name at Gmail. Or just talk to me later today. That's it. Did I go over?
You're just about